All right, so let's continue talking about how we build science lessons. We already know that we're going to focus on a core idea within science. You're going to select your essential element within that core content area. You already know how to embed a concept statement. We've already talked about wonder stories. So now the next step we're going to do is we are going to plan to use an inquiry-based instruction process. And so when we think about inquiry-based instruction, when I was in school, they taught us that in elementary school, science was more teacher-directed. So the teacher was leading the lessons, the teacher was leading the experiments. And it wasn't until students hit, those upper grades, high school, for example, that then it became more student-directed. So the students started carrying out the experiments, for example. But I want to caution you against that. That is not what we do. That is not what we do. In elementary school, it is still not a teacher-led or a teacher-directed lesson. It is student-directed as much as possible. Now, that doesn't mean that the teacher doesn't lead some of it if needed, but it is primarily student-directed. The students are exploring the materials. The students are carrying out the experiments or investigations. The students are collecting and analyzing data. And so I want to just really push that it is a big flip in the way that you think about instruction, because most often when we're teaching things like math or we're teaching literacy, that is a more teacher directed lesson or teacher directed instruction. So you kind of have to reframe the way you think of teaching when it comes to science, because more often when teaching science, you are in a supportive role. But now you plan for this, right? You plan it out so that then the students are the ones who can come in and be more directed. It's not like they just go in willy-nilly. You plan for that. So we've talked about the disciplinary core ideas, things like life science, physical science, earth and space science. So now let's move on to the science and engineering practices. And if you'll recall, when the next generation science standards were created, one of the reasons that they were created was because the National Research Council realized that we were missing those things. When I was younger, we were taught vocabulary and we were just taught a lot of facts about science, to be honest with you. There was not a lot of exploration or experiments. Now, there were, I do know that we did the whole frog thing when I was in high school. And then when I got to chemistry, we did a little bit more of experimentation. But if you stop and think about it, I just watched a 60 Minutes show on going to the moon. Us going to the moon again since we haven't been in quite the long while. But in order to even think about going to the moon again, they had to do research, they had to do investigations, but that doesn't work. They can't just know about going to the moon. They then have to come in and use these science and engineering practices to create a space shuttle or a rocket or to understand propulsion, for example, and then create the equipment or device needed to propel a rocket or a space station into to the moon. And so when we're talking about science and engineering practices, these are what they are. And you're going to have multiple science and engineering practices embedded in your science lesson. And it's going to be things like students asking questions. And I want to let you know, again, you have to teach asking questions. Our students don't always just naturally begin to ask questions. That is a skill we explicitly teach. So science and engineering practice are things like asking questions and defining a problem. What is the problem that we're trying to solve? Developing and using models, and we'll get to see that in just a minute, what that might look like. Planning and carrying out investigations. Analyzing and interpreting data. We already saw in math that our students can and do analyze, interpret data, and they can collect data, for example, weather in different regions in the winter to see where it's the coldest in Montana versus Utah versus North Carolina, for example. It is another great place to embed math as well as information and computer technology. There are great, great, great simulations out there. If you are talking about flooding, there is a simulation out there where you can not only simulate a flood, but you can affect it. You can tell it for example, how high you want the tide to be when it comes in. And you can see the impact, for example, if you're talking about hurricanes, when there is a 6 foot tide based compared to when there's a 12-foot tide, for example. Great place for computational thinking. If you're comparing things, you're comparing the weather here and the weather here, you're going to have to, for example, find the average temperature in each of those places. Students are going to construct explanation and design solutions, and they're going to engage in argument from evidence. So when they make a claim, and we'll talk about a claim in just a little bit, when they make a claim, they have to back it up by evidence and reasoning. For example, I know that let me stop and think. I should have thought about this ahead of time, right? I know that animals change over time because we saw a video of a puppy that grew from and you might have measured it, this small puppy to a teenage dog or a medium-sized dog to a really big dog. I actually saw that. I saw a video of it. Or I know that because my dog used to be a puppy and now it is a full-grown dog. And so you could back up that claim with evidence and reasoning. And then students are going to obtain and evaluate information. If you're doing an investigation, for example, you're obtaining information, and then they're going to communicate that information. So when you do an experiment, you're going to report those results, right? What came out of that experiment? Anytime I do research, I report my results. So how are we going to communicate that? Maybe we're going to make a video. Maybe we're going to do a poster. Maybe we're going to do a report. When I was teaching, the last couple of years I was teaching, my first graders always did an animal report where we did an investigation into animals, like what do they eat, where do they live, what are their babies called, for example. And we created a report because that's what they were doing in Gen Ed. And then they had a tea where the parents came and they shared their reports. That's how they communicated information and the results of their investigations. So again, science and engineering practices, you can see multiple of these practices will be in your science lessons, and you think about those ahead of time to make sure you're including them. All right, so next thing I want you to do for your participation is I want you to look at two of these, choose two of them. Some of them are concept statements, some of them are wonder questions, and I want you to come up with either an experiment or an investigation that then results in a model. And you can use the internet to help support you with this. So if you were teaching that the sun and the moon are in the sky, I've already used that one, but you could use a different experiment because there are lots of them. What is an experiment or a model that you might use? Or if you're talking about how what makes a wave bigger or smaller, then maybe you're going to do again use a model, or you're going to look online and find a simulation. So for two of these, I want you to look for an experiment or an investigation and tell me what you would investigate. We're going to use videos, we're going to use a simulation. I'm going to read a book related to this. If you can really come up with it, it is great to go ahead and put that in your lesson, because if you can find a video on YouTube, a lot of times they show you the experiment. So not only do they tell you what the experiment is, but they carry it out so you can see it. So if you can find that, go ahead and put that link, because you'll want it when you get ready to teach your lesson and to write your lesson plan. All right, go ahead and find experiments or models for two of these and then come on back. All right, I look forward to seeing those. I love science, and man, I really love experiments. It's just so much fun. All right, so here are some examples of models and experiments that you might have done. What was the one about the eye? How the eye sees in light and in dark, okay? So the first one here, this is the one that's related to the rotation of the Earth and the Moon. And so you could create this. You could create a simple model where here you have them attached, and you can actually move the sun, or I mean the Earth around the sun, and you can actually move the moon around the Earth. So that's a model that your students could create. If you were talking about the life cycle of frogs, here's another model you could create with your students. And it might be that what you've done is that you have watched a video on the life cycle of frogs, and then you have talked to the students because we're using UDL, remember? Then we also have an image, a picture that we can show that shows the life cycle of a frog. They also have these little like plastic or rubbery resources where this is the eggs and students can actually hold them. And here is what a tadpole looks like. And here's what a tadpole looks like at each of the different stages. So you might use this as a model, and that might be part of the other things I discussed, might be part of what you did for your investigation. All right, so here are some experiments. So the ones on the left are models, and the ones on the right are experiments. And so how do our eyes see in light and dark? So here you might start off where you don't have this hole right here in the box, and you have an object inside, and you want to see what can you see when you don't have that light. Then you're going to put a hole in it, and you're going to do natural light. What do I see? What do my eyes do when I only have natural light? And then I'm going to turn on the lamp, and I'm going to see what is it like when I have artificial light. Or maybe you're going to take the object out of the box next and see what is it like when I have full light, for example. So that's one experiment that you could use. Or you could use something like a wave bottle, right? You can make the determination of how much force is in there, or the tilt of the bottle, and how that affects the waves. So again, those were just some experiments. And so what I want you to do now is to stop the video, and you may use the internet to help you identify either an experiment that you're going to use or a model that you might create. If you create the model, I do want you to put down, just really brief, it could be 1 or 2 sentences, what your investigation is going to involve. Is it going to involve a simulation you find online? If it is and you find that link, keep it. Is it going to be a YouTube video or a video? You can put in a search, and YouTube has great videos on different experiments you could use. Are you going to read a book, for example? So again, stop the video, and I want you to come up with what you might do for your science lesson when you implement it, related to either an experiment or an investigation with a model. All right, and you can use the internet to support you with that. I'm perfectly fine with that. All right, so go ahead and stop your video, and then come back when you have your experiment or your investigation and model. All right, I look forward to seeing those. Again, I love experimentation. I love it. I love it. The kids love it too. All right, so we're going to keep moving. The next thing we want to make sure that we're doing when we're planning our science lesson is that we make science meaningful for our students. And the 2 ways we're going to do that is we're going to use a wonder story. We already talked about that. That's related to something, some type of daily activity, something that's going on in the world, something our students can connect with. And then we're also going to use hands-on experiments or models that are going to help us build these concepts, that are going to help our students build an understanding of what we're teaching. And here's an example of what that might look like. So sometimes at night, this is my wonder story, sometimes at night I go outside and see the moon. Last night I looked in the sky and saw a full moon. My grandma says sometimes you can see the moon in the day too. I've only seen the sun in the day. I'd like to see the sun early when it makes the sky turn colors. I wonder, where are the sun and the moon when I can't see them? Now that to us might not sound like what do you mean when you can't see them? But that is very common for students, and it is it's a misconception. That's what it is. It is a misconception. There are many students who believe when I can't see the sun, it's gone. It doesn't exist anymore. When it is daytime, the moon is gone. It doesn't exist anymore. So one of the ways that we can use things like a wonder story, an experiment, or a model to help build that concept understanding of that when you can't see the moon and the sun, they still exist, is well, you might do something like this. And this is how these help build that concept. And that's what I want you to focus on right now, is not just the experiment or the model, but how does it build the concept that when you can't see the moon and the sun, they still exist. So you might do something is like use large balls, and each one of them stands for something different, and you would want to size them differently. This is the earth, this is the sun, this is the moon. And then you have three students, one with each of the balls, and they would rotate like the sun rotates around the moon, the sun, excuse me, let me start that again. And they are going to demonstrate the rotation of the earth around the sun. They're going to demonstrate the rotation of the moon around the earth. They're basically a role model, right? They're using role modeling to demonstrate that as well as being a model by having those balls. And then when their backs are to the sun, you tell them ahead of time, you can't look behind you. You have to keep looking straight. Remember, you're an Earth. You're an Earth. Earths can't turn around. And so when their backs are to the sun, you stop them and you say, can you see the sun? And they're going to tell you no because they can't turn around and see it. And then you ask them, but is the sun still there? And then you allow them to turn around and look. And when they look, guess what? The sun's still there. It didn't disappear. And that helps to build the concept that the sun and the moon are in the sky even when we can't see them. So you can see how that wonder story, because the grandma said that you can see the moon during the day, it's not gone when it's daytime. You can see it sometimes. And then that modeling or hands-on experiment build that concept.